So yesterday we were stretching it by 2, so we said, okay, is there really that much that we have to worry about? Like, why are we talking about all these key points and equilibriums and maximum displacement top of the wave and bottom of the wave, maximums and minimums? What's the big deal? Let's just stretch it by 2. Okay, sometimes, yeah. Sometimes take the normal sine curve and just say, oh, I'm going up to 2 and down to -2. I'm stretching it. That's all the difference. 0 times 2 just still is 0. Those y values don't change, just the 2 and -2, and all the ones in between will get doubled. Like instead of being at 1/2, wait, when is sine at 1/2? 1, 2, 3, 1. 1 over 2. That's at pi over 6. Okay, so instead of pi over 6 just going up 1/2, pi over 6 is now going to go up to 1. It's been doubled. So anyway, if you just are stretching it by 2, it's not a big deal. But what do I have up here on the screen right now?
Up and down.
Ooh. Has it been stretched?
Yeah.
Yes, there's a multiplication on the outside. Has it been horizontally dilated also?
Yes.
So it's been vertically, I didn't want that color. It's been vertically stretched by a factor of 4. It has also been horizontally shrunk by a factor of 2, aka multiplied by 1/2. Oh, because horizontal is always the reciprocal of what I think. It's also been vertically shifted, and it's been horizontal. Oh dear, I mean, this guy's a mess. Has had all
Why
4.
is that the vertical thingy on the other side? Shouldn't it be on back?
Oh, you could.
That's just confusing.
Well,
No, it's not.
hopefully it won't be too confusing. Technically, it could be written like, I guess minus 2 instead of plus and -2. But yeah, you could have written it like that. But Alec, usually when we have things like ln's or things like sines, even though we could write stuff after those nasty arguments, and I'm not saying you're not allowed to, technically this is seen as more confusing and less standard than putting the easier expressions in the front.
Okay.
I don't know why, it's just a thing. Well, I do know why. Like, if the parentheses weren't there, it looks confusing. With the parentheses, it's a little bit less confusing. But you'll see on the next page, the standard form actually always assumes the guy's written in front. So maybe that'll help just a little bit. But you're right. You're used to it being down here. So we have a vertical shift, we have a vertical stretch, we have a horizontal shrink, actually, and we have a horizontal shift. Now, so we're supposed to do all of these things to a wave, to 5 different points? There's a better way.
Light work.
There's a better way.
Okay.
You could try to graph it in your calculator. Sure, why not? I don't know, man. Graph it in your calculator. Make sure you're in radian modes, because this is a pi over 4. They're not talking about degrees shifting. They're talking about radians shifting. I don't mind if you throw it in your calculator. My question is, once you throw it in the calculator, how could you graph it precisely, showing me exactly all 5 of the key points? Because that's what I'm going to be graphing if you got all 5 of the key points in the right spot. In radians, not in decimals. In nice little pi expressions. How could you graph this in your calculator in a way that you show me all 5 of the key points exactly, precisely, in terms of pi radians, not decimals?
Sinusoidal. Sinusoidal.
Mode needs to be in radians. My y equals is there. I need to clear that out and clear this out. You guys can help me out with the sinusoid. It's -2 plus 4 sine of 2x.
2x minus pi over 4.
Okay, so if you guys graph this guy, let me do a zoom standard just because. Woo! All right, all 5 of the key points. Where are they?
On the graph.
The key points. I need to know when it's like still water, where it's in the middle, and then when it's at the top of the wave, and when it's still water, when it's at the bottom of the wave, still water. Because it's a sign. I need beginning, top, middle, bottom, middle. So how do I find it? Yeah.
max is at pi over 2. The first.
So you're looking at pi over 2. Let's see. Pi over 2. Keep thinking. How do we find all 5 of our key points?
You divide the period.
Second trace maximum.
Second trace. Okay, so if we did find the max, I'm guessing we should find the max at the very first max, because maybe that's the one I know. What's 1.1780975 in terms of pi radians? Is that pi over 5, or pi over 4, or pi over 12, or pi over 3, or pi over... Aw, stink. We have to go back here and start testing pi's. Oops, maybe. You found the same first one that I did? -2 plus 4 sine. Guys, I typed it in right?
Yeah.
You have to put it in pi parentheses.
No, I think you have to put the
You
negative.
can, but from PEMDAS would say divide first and then subtract, so I'm actually okay. And if you did put parentheses, just make sure that you have this guy on the outside and then that guy. It shouldn't make a difference though. But you are in radian mode, right?
Yeah.
That's degree.
I think.
Double check. And then when you did your,
Yeah,
it's just,
maybe I just screwed it up.
make sure you go like obviously left to obviously right. There's no magical, just make sure you're before and after. 1.178. Oh, but what was I doing? Oh, I was trying to figure out where the pi's are for that. Let's see. Let's do pi over 5. Nope, that's way too small. Okay. I need a bigger fraction, so pi over 3. Nope, that's okay, I need something even. Pi over 2.
So I don't understand what we're looking for right now.
I'm looking for 1.17 because I told you guys if you do use your grapher, you need to be able to tell me the 5 key points, which include the maximums and minimums, but in terms of radians, like with pi's, not decimals. And the problem is, Emily was like, well, there's this really cool max feature, and similarly, there's a really cool min feature, but the struggle is,
It's not in radians.
it's not in radians. So, and how are you going to find the middle points for me, guys? Like, where is the middle?
Use donks.
Down there somewhere?
Zeros.
Now, if you're really smart, maybe you realize the middle is actually going to end up being -2. Wait a minute, what part of the equation told me the middle was -2? And why am I doing that? Well, couldn't we also use the really cool intersect feature? If I was allowed to do decimals? Oh, 0.3, but what radian is that? So we could actually find like, hey, middle, top, middle, bottom, middle. We could find those with our calculator if we knew the middle, but the problem is, what are they in radians? So, okay, hold on.
Let's just sketch it.
There must be maybe a better way, and the better way does involve sketching. So, didn't we just say the middle is at -2? Do you guys agree?
Yes.
How do we know that? Where was the middle of the normal sine curve?
0.
The axis, or 0, and it shifted down 2. How do I know? Because of the vertical shift. Now, I call this by a special name. I actually call this an SA at y equals -2. I call this my SA, sinusoidal axis, the axis about which the wave oscillates. The axis about which a wave oscillates. P.S. Do you want to hear something else that moves in a wave?
Yeah.
A bicycle wheel.
What?
No, it's a what? Yeah, a bicycle wheel. No, it goes around and around and around. Yeah, anything that goes around and around and around moves in a sine and cosine wave.
Is the Cheetos commercial?
No, it doesn't. Yes, it does. If you're sitting on a Ferris wheel in a car, you, going around and around and around, are, at one point, in the middle of the axis the wheel is turning around, and then you're at the maximum height, and then you're at the middle, and then you're at the minimum height, and then you're at the middle. If we just make the x value time, you're in the middle at the top, in the middle at the bottom, in the middle at the top, in the middle at the bottom, in the middle at the top, in the middle. You're moving in a wave, even though you're just going around and around and around. Interesting. That's a whole other wave you wouldn't even thought about. But anyway, coming back. So the sinusoidal axis is the axis about which the wave oscillates. It could be when the water is stilled, or it could be like the middle of a circular object, the middle about which everything is spinning. Let's see, what else do we know? Oh, hey, We know the amplitude of the wave, because yesterday we amped it up by multiplying by 2 and it went up 2, down 2. But we're not going up 2, down 2. We're going up 4, down 4. And we're not going that from the x-axis. We're going that from the middle of this wave. So we're going up 1, 2, 3, and 4. Did you guys realize when Emily had me find that maximum that it was at positive 2? The x was weird, but the y was positive 2. Where would the minimum then be at?
Negative 4.
Careful. Down 4 from negative 2, which means, see it? 1, 2, 3, 4. Does anybody see me making handwriting lines? Now, you might not be able to see this paper. This is actually like elementary poster paper that I stole to use my forever card.
Stole.
Didn't steal, I bought it. But look, it's like the old-fashioned elementary writing numbers. Remember that with the letters and the numbers? You had the little dash line. What were those lines for? The little dotted one was to say, hey, this is the middle. And what was the top and bottom?
The min and the max.
The top and the bottom. So guess what we're doing for our waves? Tops and bottoms and middles. Why? Because our wave is going to fit in between that. Our wave is going to fit in between that. Now, hold on. To make our wave, don't we also need to know where to start it and where to stop it? Where to start it and where to stop it. Well, this doesn't really stop. It actually goes on forever. But where to start it, we need to look at the horizontal shift. Because doesn't it usually start at the origin? But that's been shifted. So we need to figure out where that shift landed it. Now, here's the hard part. Do you see how there's not like a multiplication happening to everything, but just to the x, and this little minus pi over 4 thing? We need to kind of rewrite it by pulling out the 2 so we can see the stretch, shrink, the horizontal guy, separately from the shift. So if I divide by 2, wait a minute, divide by 2.
Pi over 8.
I've been teaching algebra factoring. When you factor, you divide. That 2 goes away. What's pi over 4 cut in half? Alec was right, pi over 8. I know it's kind of awkward, but it's right. We divide by 2 when we factor. Wait, so this is going to start pi over 8 to the right? Does anybody want to throw in pi over 8 and see if that's that weird 0.3 thing as to the intersection with the axis? Because pi over 8 should be where sine, which starts in the middle, is starting. What's pi over 8?
0.39.
Ah, it was the intersection with the middle that I had a second ago. And now I have it in radians. It's pi over 8. Now question. I have my first key number. It is pi over 8 and negative 2. Now I need my maximum. Well, wait a minute. Hasn't this been stretched? So do I just go one quadrant? I just add pi over 2 and I'm here, and then add another pi over 2 and I'm here, and add another pi? No, it's been stretched. Or more
multiply pi over 2
specifically.
by 4.
Well, I think I need to think about this thing that someone was mentioning. Period. What's the normal period of a sine or cosine?
2 pi.
2 pi. And either that 2 pi is getting multiplied to be bigger or divided to be smaller, depending on a horizontal stretch or a horizontal shrink. What did we say this one is? A stretch or a shrink? A shrink, because horizontal always works backwards. If I see it 2 times, doubling! No, it's cutting in half. Oh. So there is like a, no, careful. Vertical will be on the outside of the sign. This is technically on the inside of the sign. See it? Kind of weird. Because then the sign would be on the outside. So the, yeah. And that's why I did an amplitude of up 4, down 4 for my waves. So I'm going to take that 2 pi and say, it's not times 2, it's divided by 2. I'm going to take whatever number is there and actually divide or multiply by the reciprocal for period. So how long does this guy have to complete? Just pi. Now wait a minute. This gets confusing if I'm working in eighths. No, it doesn't. How many eighths, guys, will be there if it's a whole pi? No, if it's a whole pi. 8 eighths, right? Oh, so if I need to go 8 eighths from this guy, where am I going to land? Well, 1 eighth. 1 eighth. From this guy. 1 eighth, 2 eighths, 3 eighths, 4 eighths, 5 eighths, 6 eighths, 7 eighths, 9, 8 eighths. Which would be 9 pi over 8, right? But if I'm going 8/8 and I need to move in quarter cycles because I need to go a fourth and get another point in the fourth and get another point like the 4 quadrants, what would be a fourth of my 8/8? 8 pi over 8 cut in fourths. Oh, that'd be 2 pi over 8s, right? So I'm going to go 2 pi over 8 to get to the max of my wave. I'm going to go 2 pi over 8 to get to the middle of my wave, 2 pi over 8 to get to the bottom of my wave, and 2 more pi over 8 to get back to the center. Ready? Let's see if we did. Because I have my maximum being at 1, 2, 3 pi over 8. 3 pi over 8. Is that elusive 1.17 weirdness that I couldn't find? And then for 5 pi over 8, it's going to be back at my -2. And then 7 pi over 8 is going to be down here at my -6. And then back here at the middle at 9 pi over 8. Hey, let's check in. Let's trace. So, pi over 8. Boop, 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 boop. Is he in the middle? Yeah, he is. Sweet. 3 pi over, oops, let's go back to my trace. Yep, back to trace. It's a shortcut. The trace is the value button. 3 pi over 8. That better be at the top. Yeah, it is. 1.17. 5 pi over 8. Do you guys trust me yet?
Mm-hmm.
How much math did it take for us to figure these out, though?
A lot.
A little bit. Was there a pattern, though, do you think?
Some.
I feel like there was a pattern. And then 9 pi over 8. Did I find my 5 key points? Yep. How do I keep going? I just draw little arrows and say, hey, the wave keeps going, right? So, what did, wrong one. What did, we already did that. What did we just do? Well, it can all be summarized in this little page right here. Alex, do you see how the shift is in front? The plus or minus is in front, but you're right. It could have been written over here. Just rewrite it in front. There are these little numbers I went looking for, guys. I went looking for who is this guy, who is that guy, who is that guy, who is that guy, what's going on. Sometimes there's nothing being added, so that's a 0. There better not be a 0 here, or else we have no trig. It's just going to be a line. A 0 here, we're in trouble because then there's no x, and so it's not even an equation. It's just a number, and if a 0 is there, oh, whatever, no shift. So you could have zeros in the shifts. You probably won't have zeros anywhere else. You probably won't have zeros anywhere else, but there could be zeros in the shift. Now, guys, there are 2 different forms, and maybe you realize that the one we just did fell under this form because we had the y equals -2 plus 4 sine of 2x minus pi over 4. I gave you one written like this top form. What would have been its form if it was the bottom form? What was the one thing that changes? You still have d, you still have a, you still have your trig. What's the difference?
It's when you take the factor out.
Which I needed to do eventually anyway, right? So, actually, to be honest, this bottom one is probably a little bit better, but you'll usually be given the top one, and you have to do this step yourself of dividing. And when you divide, well, that little pi over 8 thing, when you pull out a b, you have to divide by this guy, the b goes away, and divide by that guy. That's how we factor. It's just kind of showing you the factoring step. But when I was doing all this math, maybe it made sense, and you're like, oh, she's just doing transformations. But did you realize what we were finding? We were finding the sinusoidal axis which is the same thing as the middle of the wave. The middle line, right? We were finding the sinusoidal axis. Where did it shift? Is it still on the x, or did it go up, or did it go down? Where is this oscillating around? A Ferris wheel wouldn't be on the ground. The middle of the wheel is not on the ground, or that's a weird Ferris wheel. You're like going underground.
But take it out.
Actually, that could be cool if they had like made a display underground, like finding Nemo. Anyway, it could be cool. Right? Like if you like went under the sea and you went up. Anyway, somebody become a ride designer. A lot of engineering is required for that. Anyway, so The middle for the Ferris wheel would be off the ground, and so far off the ground that it would have to account for the entire size of the wheel, right? But also some space so you don't like hit the ground when you come down. That'd be bad. It's even higher. Anyway, that's the middle. Yeah.
I have a question about the graph that we did.
With all the changes?
Yeah,
Give me a second, just because let's label everything. Then I can use correct terminology when I'm pointing at stuff. Is that cool? So we have the sinusoidal axis, which is that number in front, plus or minus, that's shifting the middle of the graph. Ours had a -2, so it shifted down 2. And we put the middle line at -2. This next one is the amplitude. I said the word a couple times, yesterday and today. Amplitude. If you amp it up, what are you doing?
Making it louder.
Turning it up, making it louder, making the sound waves taller and more stretched too. So amplitude.
I have an amp. Like 5.
Sweet. We can find the maximum line. Let's see, how do I write this? The amplitude is A. I think I'm going to go straight to this guy, which means my max is going to be at D plus A, and my min is going to be at D minus A. If you guys noticed, I started from the middle and went up A to find the highest the wave could go, and I went down A to find the lowest the wave could go. Now, technically, I don't look at B next, because B has to do with the horizontal stretch, which is great and all, but that shows me how long. I need to know where to start the wave before I think of how long to make it. So I actually look down here at C over B for the starting point, or for the starting X. C over B is known as the phase shift, or you could also say phase displacement. The phase shift or the phase displacement.
And speak a shred of phase.
At X equals C over B. Now be careful, we've had to get used to this whole minus thing. Like x minus h quantity squared plus y minus k quantity squared, like hk is the vertex, even though there are minuses. So we're going to have to do that here as well. But what this means is that the initial point is going to be at the ordered pair C over B. If it's one of these where, okay, we have to take the B out sort of thing, it's this number, and it's just whatever's in this spot. You don't always have to, it's not like a formula you necessarily have to plug in. It's whatever is in this spot once you have this guy pulled out, whatever's in this spot once you have that guy pulled out. And, well, here's the struggle. Sine started at the middle or on D, but cosine is actually going to start C over B. Cosine starts up at the max. And then what we're left with is B. And B was the guy that was used to find the period. Technically, he's not the period, though. B is actually, well, 1 over B is the horizontal dilation. But what that means is my period, that 2 pi that is normally there, gets multiplied by 1 over B. And then I know how long to make my wave. I know it's a little bit messy in the sense of writing out all of what we did. But we basically tear apart or break apart an equation to see who is the D, who is the A, where is it starting, and then how long do I make it. But guys, if we can put all those pieces in, we can draw our wave, and there we go. Now hold on. Why is this homework not due tomorrow? Because there's a lot more. We haven't done many examples. So we need to do examples, but you guys have gotten the key pieces that we need to use. Sound good?
What about
Priyanka, I get the other question, you can ask it now, or you can hold on to examples.
Just do our test.
Oh, I have them. If you want them, you can